Earthquakes, tremors remind us of the immense forces beneath our feet, capable of unleashing devastation, altering landscapes. Humanity often stands helpless against their raw power. But what if we could change that? Could we control these seismic giants? To even fathom the idea of controlling earthquakes, we must first understand the mechanics behind their awesome power. The Earth's crust, far from being a single solid shell, is fragmented into numerous tectonic plates. These plates, in constant albeit incredibly slow motion, interact with each other, creating zones of intense geological activity. Imagine a slow-motion ballet where the dancers are gigantic tectonic plates. As they push against each other, immense pressure builds along their edges, known as fault lines. These fault lines, often hidden deep beneath the surface, are where earthquakes originate. The pressure eventually overcomes the friction holding the plates in place, resulting in a sudden, violent release of energy. This energy radiates outward in the form of seismic waves, similar to ripples spreading from a stone dropped in a pond. These waves, traveling at incredible speeds, cause the ground to shake and tremble, sometimes with enough force to topple buildings and reshape the very landscape. Understanding the intricate dance of these tectonic plates, the buildup of pressure and the release of energy in the form of seismic waves, is crucial to even begin contemplating the possibility of controlling earthquakes. While earthquakes are a natural phenomenon, it's becoming increasingly clear that human activities can influence their occurrence. We are, in a sense, capable of leaving our own seismic footprint on the planet. Certain industrial practices, while seemingly benign on the surface, can have unintended consequences deep within the Earth. Take, for example, the process of hydraulic fracturing or fracking. This technique, used to extract oil and natural gas from shale rock formations, involves injecting fluids at high pressure into the ground. While effective for its intended purpose, fracking has been linked to an increase in seismic activity in certain regions. The injection of fluids can alter the pressure within existing fault lines, potentially triggering earthquakes. Similarly, the disposal of wastewater from fracking operations, often pumped deep underground, can also destabilize fault lines, increasing the likelihood of seismic events. Beyond fracking, activities like mining, geothermal energy production, and even the filling of large reservoirs can all impact the delicate balance of pressure within the Earth's crust. The realization that human actions can influence earthquake activity presents a complex dilemma, forcing us to confront the unintended consequences of our pursuit of energy and resources. Decoding Earth's tremors. Recent advancements in technology are providing hope. Sophisticated methods monitor and analyze Earth's movements. Sensor networks detect slight tremors, groundwater changes, and magnetic field variations. AI analyzes data, identifying patterns and anomalies. Early warnings can save lives and mitigate damage. Section 5, Taming the Tremors, a glimpse into the future. The notion of controlling earthquakes, once relegated to the realm of science fiction, is now being cautiously explored as a tantalizing, albeit distant, possibility. While our current understanding and technology are nowhere near the level required for such feats, theoretical concepts are emerging that hint at a future where we might be able to mitigate the destructive power of these seismic behemoths. One such concept involves strategically injecting fluids into fault lines. By carefully controlling the pressure and location of these injections, it might be possible to release accumulated stress gradually, preventing the sudden catastrophic rupture that characterizes a major earthquake. Another avenue of research focuses on manipulating the propagation of seismic waves. Imagine creating artificial barriers or structures within the Earth that could absorb or redirect the energy of an earthquake, effectively shielding vulnerable areas from its most destructive effects. While these concepts are still in their infancy, requiring significant advancements in our understanding of geophysics and engineering capabilities, they offer a glimmer of hope that we might one day be able to tame the tremors that have haunted humanity for millennia.